All right, good morning, folks. This is your warm-up for today. Please jump right in and throw that data into Staplet, create the LSRL, and then find your S and your R squared and interpret, please. Once you're done, unpause this video and then check your work. So we should be good to go. If you plug that data in correctly, here's your LSRL. Make sure you've got everything defined, or you could throw your actual context into the equation. Your S and your R squared are there. Please look at the interpretations and make sure you've interpreted correctly. If not, go back and redo those right away, as that's super important to what we're doing. Let's jump into today's lesson. We should be looking at how many iPhones will be sold. We have our data here. You're going to want to start by throwing that data into Staplet and looking at the scatter plot, then determining whether it's linear or not with the residual plot. And if it's not, how could we transform it? What type of model does it look like? At that point, you're probably going to want to pause and come back to me so that we can look at what you should have and then move into number 4. So press pause, try 1, 2, and 3 on your own, and then we'll jump in. All right, if you've done that correctly, your scatter plot looks like so. My residual plot is here as well, and I can clearly see that there is no, this is a no. This is not appropriately linear because there is a residual, there's a clear pattern in the residual plot. We have a U-shaped pattern, so linear is not appropriate. So maybe what is? When I look at that graph, it clearly looks like maybe it's exponential. So I'm not entirely sure, but that's what I'm going to go with for now. So I'm thinking, all right, exponential. What is the model for exponential? Well, hopefully you remember this back from Math 1. Your model is y equals a times b to the x power. But what you might not remember is what the inverse is of that function. And an inverse of an exponential function is a logarithm. So we're going to have to do a little bit of math here in order to transform our data using that inverse. So first thing I'm going to do is just going to rewrite my equation, y equals a times b to the x power. But in order to use the inverse, we're going to need to take the log of both sides. So if I take the log of the left and the log of the right, I lost a little bit of my x there for some reason. So log of the left, log of the right. We're going to use our exponent properties here to expand what we've got on the right-hand side. If we take the log of a product, that expands to addition. So log of A plus log of B, which would be raised to the x. But if you remember the last property, any power actually comes down in front as multiplication. So it's no longer up here, and we have this. The great news is that this is simply a number, and that is our y-intercept. And then this is simply a number, and that is our slope. So if we look at our new equation, we now have the equation log of y equals log of a plus x times log of b, which is our slope. That's exactly how we wanted it. And we're going to use that equation jumping into part 4, number 4 here. So with number 4, what we needed to do is essentially we're asking you to take the log of your y values. So that's what I'm about to do right here, is I'm going to take the log of 0.5 and say, what is that value? So if we take the log of 0.5, you end up with negative 0.3, so negative 0.301. Take the log of 1, and you end up with 0. 0 again. I'll just give these to you really quickly. 0.23, 0.60, 60 there, 0.70, and 0.95, exactly 1, and 1.11. So we're just taking the log of every single one of these y values, and then we're going to plug that data into Staplet. So these are my new x's. Sorry about that. These are my new x's right here, and these are my new y's. So when we plug that data into Staplet, you're going to get a scatter plot that looks much more linear. You can see that it looks much more linear to us, and that's exactly what we were hoping would occur. So when we look at that, let's confirm it. If we go ahead and we find the LSRL, so I'll give you that equation really quickly. Assuming you've plugged that into Staplet here, you would get the same. Y hat equals negative 1.54 plus 0.18x. Okay, and then we could look at the residual plot, and here we have it. In this case, we are good to go. Yes, linear is appropriate because there's no clear pattern in our residual plot. And at this point, I'm feeling really good, but I'm going to stop you right there because we've made a few mistakes on the way. Remember, we took the log of all of our y values. So that's the first thing we need to fix, is that on the y-axis here, this is actually the log of the number of units sold. It's not the number of units sold, it's the log of the units sold. The x can remain the same, that's not changing, which means then my LSRL is wrong as well. I need to take the log of y hat equals negative 1.54 plus 0.18x. It's no longer that. So off to the side here, one other way you could write this would be log of the units sold. Okay, don't forget your predicted, so your hat equals negative 1.54 plus, I'm going to run out of room, but 0.18 times the number of years since 2000. Okay, so remember, you can plug in your context directly in that sense if you'd prefer. But we are now going to use that equation in order to start making some predictions. So notice here, what you probably would have done initially is you would have just plugged in 15. So don't forget that in this case, our x value equals 15. So that's all I'm going to do. I'm going to take my initial equation, log of my number of units sold, so log of y hat equals negative 1.54 plus 1.8 times, and here's where I'm plugging in my value of 15. When we do that, you have to be very careful because now we're going to have log of y hat equals, if you simplify this, it gives you 1.16. And a lot of people will think, well, then that's my answer, 1.16. But it is not, because we need to get rid of the log on the left-hand side of the equation. We don't want log of y hat, we want y hat. So the only way to do that is to raise this as an exponent. Now my exponents are log y hat and 1.116. So once we exponentiate both sides, the logs cancel out. I'm left with y hat equals 10 raised to the 1.16 power, which is 14.45, and that is 14.5 million iPhones. Okay, so we've got our context there. The next piece is to figure out, well, then what's my residual? Calculate and interpret the residual for 2015. So if we go back to our equation, we remember that a residual is the actual minus the predicted. And so we can plug in our actual. Our actual in 2015 was 13 million iPhones. So 13 minus our predicted 14.45, which leaves us with a residual of negative 1.45. And if we interpret that, that means that the actual number of iPhones sold in 2015 was 1.45 million below the prediction. So at this stage, we have all of our residuals calculated. It's really key that we have an understanding of the fact that a logarithm, converting it into exponential form and using our new equation, gave us an equation that we can now use to make predictions. But be very careful as you navigate this. So very quickly, our important ideas. Want to make sure you have these written down. Linear, don't forget our linear equation. Originally, I just want you to write that in here on this line. Our originally linear equation was y hat equals a plus bx. And this is not really changing because this is still x versus y. So our equation here is still y hat equals a plus bx. But things are changing for what's called a power function and an exponential function. A power function would be something along the lines of y hat equals a times x raised to the b power. And if we want to convert anything that's a power function, we're actually going to need to take the log of both the x and the log of the y values. So we're taking the log of both, which means that now my equation is now log of y hat equals a plus b times some value log of x. So it's really important that you understand that's our new equation there that we would use to transform into linear. Exponential is what we've just worked with. So here it's y hat equals a times b to the x. And that's, the x can stay the same. It's not touched, but we are going to take the log of the y values. So our new equation is log of y hat equals a plus b times x. That x is untouched. So you can see here just a quick reminder on how to make our predictions. Some calculator steps there. We need to make sure that we are raising this to the 10th power, or excuse me, 10 raised to the a plus bx. Solve that. Don't forget this intricate step in the process. We've got to make sure that we do 10 raised to the a plus bx. In this context, you could also use the natural log if you'd prefer, which would give you a base of e. So here it's important to remember to check this. The first thing to do here is to check the scatter plot for a linear pattern. All right, we always want to make sure that we have a linear pattern. Next thing to do is to check the residual plot for no clear pattern. We don't want a clear pattern in our residual plot. And the last thing we can do to see which regression model is best is look at your R squared and see which one has it closest to 1. So at this point, I want you to jump into the check your understanding. Immediately stay with me because I want to talk through what this information is here in this what's called a computer output table. Our computer output table is this large rectangle right here. There's lots of important information that I want to identify for you. And then I'll let you jump in and try the equation. So we've got some context here, but I'm going to focus mainly on what's in this computer output table. And really I want you to begin by crossing off a number of values, because we are not going to use most of the data that is in this particular table. We're not going to use this information, we're not going to use this information, we're not going to use this information, and we're not going to use this information either. So you can cross all of that off for now. The constant is your A. So this value right here is your A. And then the height right here cubed, in this case, is your B. So we are giving you the slope of your equation right there. And then obviously this number right here is your S, and this number right here is your R squared. So just a quick note that if you wanted to be able to find R, you would need to be able to take the square root of that particular number right there. Make sure you write it as a decimal, so 0.996. So I'm going to set you loose, find your least squares regression line for this first one, and then use that to try and make some predictions in part B. There's a second equation, or second check understanding there, where we give you several scatter plots with their residual plots, and you want to use those to try and model the life expectancy for residents of a county. So do your very best there, and we will chat about those soon in class. Good luck. Keep up the great work.